All right, so we're going to talk about some logic. This is mostly going to be a review for you. You should have learned all of this in 201, but it's worth talking about again and pointing out some new things that we might be really focusing on here in this class. All right, so start with the basic building blocks. Statement. So a statement or a proposition, all right, same thing, two different words, is a sentence that is either true or false. All right, and what's not really stated here is all the time. It is all the time either true or false. And so all cars have wheels. As far as I know, that is always true. And so the sky is red, not a proposition. All right, so yes proposition, not a proposition. Sometimes the sky is red, sometimes the sky is blue. Without stating more information, that's not a proposition. Because sky red right now is sky red at sunset, sky red at sunset on this day. All right, so we'll do some examples and talk about this a little bit more in class. But statements are the basic building blocks of theorems and really therefore mathematics. And so understanding what a statement is and what a statement is not is really important. So like I said, we'll talk more about that in class. But the next thing we have, combining statements to make new statements. All right, or another way of thinking about this is statement operations. All right, so I'm given a set of statements. What can I do with them? All right, in the same way that with numbers, we can do things with them. We can add them and subtract them and multiply them and stick a negative sign in front of them and get new numbers. Well, we can do the same thing with statements. We can take two statements, put them together, get a brand new statement that maybe says something more important. So you know all of these things, but I'm going to go over them real quickly. So first, let A and B be statements. We have the following operations. Not A. All right, so not A is a statement. It's called negation. Symbolically, we write that statement as this little symbol here, A. And not A is true whenever A is false. Okay? So that's a new statement, and to determine whether or not it's true, you look at A and basically change its truth value. All right, next we have the conjunction. A and B. All right, so this little thing down here means and. All right, and so this is a conjunction. All right, this statement, all right, this conjunction statement right here is true when both A and B are true. All right, together. If either of them are false, or if both of them are false, then this conjunction statement, this and statement, is false. All right, and that makes sense. That's exactly how we would think of the word and. All right, next we have a disjunction, A or B. All right, so that symbol right there means or. That's a disjunction. All right, and so this whole statement, A or B, is true if either A or B is true. One of them could be true, both of them could be true, whatever, then this whole thing is true. The only time that the or statement is false is when both A and B are false. All right. And next we have really probably the most important one that we're going to use in this class, which is the implication. If A, then B. All right, and so this is called implication. Symbolically, we write this as A double arrow B. All right, so this right here is a new statement. All right, and this is true if both A and B are true, or if A is false. All right, so if both A and B are true, then the implication is true. If A is false, then the implication is true. All right, the only time that this new statement, all right, is going to be false is if A is true and B is false. All right, and that kind of makes sense. This is saying if A is true, that implies, right, implication, that implies that B is going to be true. So if we have the situation where A is true but B is false, well, that's not right, all right? So that means this whole thing is going to be false. And so once again, we'll look at this in more detail when we do some exercises in class. All right, so next, let's look at some truth tables, all right? I'm sure you guys have played around with these in 201. These are graphical ways of representing the truth values of a statement. All right, so let's look at negation. All right, so we have a statement A, all right, and this statement can be either true or false. All right, so what is the truth value of not A in both of these situations? Well, if A is true, not A is false. And if A is false, not A is true. All right, and so what we have right here is just a graphical representation of the truth values of not A. Let's look at A and B. All right, we're going to need two different statements over here, both A and B. We're going to have to represent all the possible truth value combinations for those. Usually the way this is done is true, true, false, false for A, true, false for B. And we look at, okay, for both of these combinations, when is A and B true? When is it false? Well, it's true when both A and B are true. And it's false if either of them are false. So the truth value for A and B is going to be given by this column right here. All right, so it's a graphical representation of the truth values of a particular statement. All right. So just like we have ways of combining statements, and that's similar to how we combine numbers with various operations, there's also the same thing as like an equal sign between two numbers. Two numbers are equal to each other if they represent the same quantity. Well, we say that two statements are equal to each other, except we don't say equals. We say they are logically equivalent instead of equal. And two statements are said to be logically equivalent if and only if they have the same truth table. Right? Or the same truth values. Sometimes the truth table is infinite, you know, you can't actually write it down. So if they have the same truth values. All right, so basically it's saying that two statements are exactly the same, it's just two different ways of writing it down. All right, so a few more definitions, which you should be familiar with. The converse of A implies B, all right, or if A then B, is B implies A. All right, so that's just what we call the converse. The contrapositive of A implies B is not B implies not A. All right, so the converse of A implies B is B implies A. These two things are not the same. All right, they are not logically equivalent to each other. But what we can show by using the truth tables is that the contrapositive is the same thing as the original implication. All right, so the contrapositive is in fact logically equivalent to A implies B. And so this leads to our sort of second way of proving things. We've had the direct proof, which is just attack it, assume the if, and then go on from there. Next, we have proof by contrapositive, which is, okay, maybe proving if A then B is too hard. Try proving if not B, then not A. And if this is true, if the contrapositive is true, the original statement also has to be true. All right, and so we're going to look at this, we're going to talk about this, different ways of proving our various statements. We'll talk about that next time. So hopefully this gave you a good review of logic. We'll keep on talking about this when we move on to quantifiers.